In this lesson, we're going to be looking at inverse trig functions. And this question is asking us to find the exact value of the inverse sine function of the square root of 2 over 2 if it exists. So remember that on our unit circle, each point on the unit circle has a coordinate pair, x and y, where the x value represents cosine and the y value represents sine. So what I need to do is I need to find a value for y, since y represents sine, that would give me this answer of square root of 2 over 2. So when I look around the unit circle, I can see here that this positive square root of 2 over 2 lands right here. So I'm going to say that the inverse sine of square root of 2 over 2 is equal to that angle that corresponds with that point, which is pi over 4. Now, looking at this next example, we're trying to find the arcsine of negative square root of 3 over 2. And just note that the arcsine is the exact same thing as inverse sine. So two ways to write that would be sine to the negative first, or as this arcsine. Now, I forgot to mention this on the earlier example, so we might as well do it now to help us with the arcsine down here. But the arcsine is actually a function that's restricted because it has to fall between negative pi over 2 and pi over 2. So that's why we could have essentially used 3 pi over 4 for that earlier angle, but since it was not in this range that restricts the inverse sine, we had to go with the pi over 4. And we're going to run into that same problem down here because there are two square root of 3 over 2's that run in the y coordinate, but we have to use the one that's between negative pi over 2 and positive pi over 2. In other words, it has to be on this side of the y-axis. So therefore, my value of arcsine of negative radical 3 over 2 is going to be this angle 7 pi over 4, or you could write it negative, or I'm sorry, it's actually, I was looking at the wrong angle there. It's actually 5 pi over 3 is what that ends up being. So 5 pi over 3 is your angle, or you could write that negative pi over 3. So in this last example, they're asking us to find the inverse sine of negative 2 pi. Now, if we look at the unit circle, notice that if we go around, the highest height we're going to get to in the y side is 1. And if we go all the way around to the lowest side, the lowest we get is negative 1. So no matter how many times we go around the circle, we're never going to get negative 2 pi. So therefore, the inverse sine of negative 2 pi does not exist. So see if you can use your knowledge of the unit circle to determine the inverse sine of 0.